All right, cool. I'm going to stand a little bit to the side. Yeah, that should work. Perfect. All right, so I'm going to be going over catalogs, Iceberg, and Delta, building the foundation for Lakehouse analytics. So, really quick intro. My name is Zoe Steinkamp. Like he said, I'm a developer advocate at Clickhouse. I've been working in the database space for over 6 years, mostly in NoSQL, like time series or OLAP DBs, not so much in like relational. I love open source. I've mostly worked for open source companies in my history, and I like the fact that open source allows people to really see how the bacon's made to a certain degree. They really get to see how things are built. But also in particular with databases, it really allows for a lot more connectivity and interoperability. And I come all the way from Colorado, which is in the middle of the US. We're famous for our mountains and Aspen and all that. So today I'm going to be going over 4 main things, which is the Lakehouse promise. Basically, that's going to kind of explain some of the history of Lakehouse 1.0 versus 2.0 and kind of how this promise is finally coming to fruition. Iceberg and Delta overview for anyone who's not familiar with these 2 technologies in particular. How Clickhouse integrates into this entire spectrum and basically is the analytical side of this. And real-time architecture and hybrid deployment, so how people actually do this in real life. So the Lakehouse promise. So originally, data lakes were built for scale, but not always for speed. That kind of just became like it was great in that they could scale up, they could eat a lot of data, they were good at that. But they weren't always the fastest. Sometimes your queries would take quite a bit of time. There was also a vision going forward that would be unifying open data formats plus performance plus analytics. That was the promise, quote unquote. That was the vision that people, when they really started to work on things like Iceberg and Delta Lake, what they were really going for. That was the promise going forward. The problem, too many lakes turn into swamps. They end up stale, they end up slow and hard to query. But that's not always going to be the case going forward. So let's first look at this. So I've purposely made this, I've made this a little bit, like I'm not going to name names or really talk too much about this, but basically you had your traditional data warehouse about 30 years ago, which is basically just like an Oracle database that had a bunch of data. That's kind of what was a data warehouse. There was really not a distinction at that time also between, per se, data warehousing and database, which even then sometimes I think the distinction's a little fuzzy, to be honest, especially nowadays. 10 years ago, you started to see the rise of cloud data warehousing. So that is one difference, is 30 years ago, all of this was on-prem, but everything was on-prem, to be fair, so it's not really that crazy. But cloud data warehousing was important in the fact that it paved the way for us to be okay with having our data on the cloud, because that is something that I think we sometimes take for granted today, especially if we work at more new companies. You know, it used to be that everything had to be on-prem. I have a husband who works in the legal tech, and he still deals with a lot of on-premise stuff. Like, they're just moving to the cloud this year. It's very exciting for him, kind of, except for he has to learn a lot of AWS stuff. But like, he has literally gone to an office during a snowstorm because it took out the server because it lost power in a snowstorm. Like, and there's not like, yes, there's backups, but they're on site. Like, his company isn't that big. They're not like, they don't have a site somewhere else that they can pull up. Like, this was the main server room in Denver, Colorado. But yeah, cloud data warehousing was big. It basically, and to be honest, the 2 that really brought this forward, I'll just say it, is Snowflakes and Databricks. They convinced people to trust the cloud, to trust the security that they had in place. They basically convinced people, like, you do not have to have this on-prem. You can put on the cloud, and yes, you can store your data. That's the other thing too. Data warehouses tend to have more sensitive internal company data, and they convince people that you can do that. You can store your sensitive company data on us, and it will be secure, and it will be easy to access, and will integrate with all the tooling that you use, like Salesforce, et cetera, which was also at the time coming onto the cloud. But now we reach the present, where we're kind of, as we call it, unbundling it. Now we have things like open data lake formats. So no longer are you, per se, like, we call it vendor lock-in, which is definitely what it used to be, but nowadays not so much. Nowadays, there's a ton of open source interoperability. There's tons of different players working on these in particular. So let's kind of take a look at this. So this is Lakehouse 1.0 versus 2.0. So it used to be that a lot of things were, like, your data format was tied to your specific vendors, or it was like a proprietary format. Your cloud storage was similar. Nowadays, you can use whatever cloud storage you want. You can use all the major 3 and more than are listed here. Your open format is by default. Like, you can choose whatever data format you desire. There's a lot of metadata translation, which basically means these kind of talk between each other. So if you're really in the mood for it, you can use multiple data lake formats. I don't necessarily suggest it, but you can. This is also great, as you inherit things. Companies started on something and now they want to move or they want to keep both going. And you have more options with compute engines. In particular, this is the big one. It used to be that your compute engine was very much proprietary to your query engine. It was very much coupled together. But now you can use whatever you want, and you can use a lot of tooling that you wouldn't have been able to use in the past. And you have a lot more options too, because a lot more, for lack of a better term, products and companies have been built on top of this. And this is kind of what it looks like on the top. So I'm talking a lot about the underlying data storage because I'm from a database company. But this is also what used to happen up on the top of this as well, which was that you just had a lot of catalog and governance was very access controlled, and even schemas were locked into your vendor system. They called it the unified owned by one, basically. But now we have catalog beyond data. It's completely again, you get to kind of have your unified single source of truth, but you can use multi-tool one system, data and logic and resource. And then again, it's just basically, we have a lot more capabilities and a lot more things are easier to integrate together nowadays. And you can kind of branch out. And in particular, this is really helping people, integrate with tooling that they couldn't have integrated in the past. And also make sure that everyone can access the data to a certain degree. It used to be kind of hard. I'm sure people remember the days, which it's still the days even today, where the sales team has to go to a data analyst team and be I need all these things. And unfortunately, it's really hard for the data analyst team to give it to them because they've got all these different toolings and they're locked in, and it's just not always the easiest to deal with. But nowadays, you can build things that are more for these teams. They can use whatever apps they want, and those apps can all feed from the data sources below, and it's really nice. It's very much the promise that we were, again, promised. And this is kind of what it ends up looking like nowadays. This is pretty common, I would say, overall. Obviously, there's more logos than what's just on here, for example. There's a ton. But in general, this is kind of how it ends up. You have your data lake, your object, which is built in with your object storage. You've got file systems. You have your data movement and transformation tools as needed. You have your data warehouses, which nowadays you have a lot more options as to what you want as your warehouse. You have integration into streaming layers, which is great for a lot of people. And you have all these different sources, which again, that's a big thing that makes, I would say the biggest distinction between DBs and in general data warehouses is just that your streaming layer, your data sources are just much more varied when it comes to ending up eventually in the data warehouse. It ends up with things like observability metrics, application layer stuff. Like I said, it might have a Salesforce integration or a few other tooling integrations that would not normally be stored in your DB. You don't normally store your Salesforce logic in your DB, but you do store it in your data warehouse so then you can make educated business decisions, for example. And all of this ends up powering things like real-time analytics, your business intelligence, as I just mentioned, and nowadays quite a lot more machine learning, data science, and Gen AI. In order to build those platforms, in order to build that for your company or even for clients, you need to basically have all your data good to go and cleaned up. So let's really quick get into Iceberg and Delta. So what are the main three open data lake formats? There's really, I will admit, there are kind of more than three, but these three are the big ones. This is kind of where everyone, for lack of a better term, is just kind of consolidated. They've all been yes, this is the big three that we're going to kind of follow. They all have creators and stewards of big companies. Netflix, nowadays Apache Iceberg is obviously with Apache, but it was originally created in Netflix. You have Delta Lake, which is obviously taken care of by Databricks. And you have Apache Hudi, which I will admit is kind of one of the smaller of the three as far as GitHub stars and just overall people, taking it on. But it was originally built by Uber. I think it also doesn't help that there's two Apache projects here that are technically quote unquote competing. But even then, that's not really fair because these don't make, they're not a company. They don't make any money. They're not competing in that way. It's really just, it's like an arms race for who can have the more features. And to be candid, I like how one person put it when they kind of were talking about this, is that they were in the end, it's reading from a Parquet file on a file system, and it's taking said Parquet file, it's organizing it in the catalog data lake format, in the data lake format, and then the catalog is reading it to your service. They were how you choose to fry your fish is your own decision, but it's a fish in the end. It's the fish being fried. They're just doing it slightly differently, which is why I put on the side here, they're both powerful, they're both supported by large companies, and they're both used worldwide. And like I said, it's an arms race. Like they're both constantly putting out new features. They're both working on becoming better. And I guess in a way it's great in that at least there's no monopoly. Like there is some healthy competition here. So they both kind of have to work as hard as they can to, continue uptake. Though I will say that I think they're both just going to continue. I constantly see articles that are like, oh, is Delta Lake winning against Apache Iceberg? And I'm like, they're both not going anywhere. Like they've both been uptaken by hundreds of huge companies who are never going to completely abandon them. At this point in time, they're just going to be together forever in their little quote unquote arms race of whatever. And again, who you choose to use is your own decision. I don't mind either way. Again, they're not companies. I don't work for them, so I don't care. We personally at Clickhouse use Apache Iceberg, but that was, again, our own decision. And it wasn't even my decision. That was engineering. But so this is kind of how, for example, Clickhouse has been working to support Apache Iceberg. So we support in that we can read off all the three major catalogs, Unity, REST, and Polaris. We support the partition pruning. We support the statistics, the cache improvements, schema evolution, time travel, and Iceberg introspection, which I would say out of like all the things that Iceberg in particular can do, the time travel, schema evolution, and partition pruning is probably like the big three. Outside of obviously the catalog, which in my opinion, if you're going to integrate with these data lake technologies, catalog is like the first thing you got to work on anyways. And then same thing with Delta Lake, except for it's really only got one catalog for us to deal with, which is Unity. And then again, the partition proving and the schema evolution and Delta kernel integration. This one just has less check marks because honestly, Delta Lake there's just less per se for us to do to integrate with it. Not that we don't care about it as much. They're both pretty strong. And when we get used by data engineering teams with these more recent core database improvements, we see about 10x faster Iceberg queries sped up between these two versions and 20x faster joins by default just by making these improvements ourselves and making these faster integrations. So let's kind of take a closer look. So this is something to keep in mind here is that, this is great on like the legacy on-prem data platform. This is like the first original examples. These and the cloud data warehouses are really good for ad hoc and what we call periodic workflows, or as we would otherwise put it, basic data discovery and generating reports. Basically, they're really good for a report that you can wait a couple minutes on, or it's for an internal person who has no choice but to wait for them. They're great for that. They were also great for, like it said, ad hoc. It was literally, like I mentioned earlier, somebody from sales coming to the data engineering team and being like, hey, I need the answer to this extremely specific question. That's an ad hoc question. It wasn't something where they, wanted it for their Monday meeting every week. It was just, no, today I'm in the mood to know this information. And that's great. That's very good. But nowadays, we also are dealing with what we call highly concurrent and interactive. So this is now immersive data-driven apps, monitoring and alerting and detections, all built on top of the data warehouse. So now we're dealing with things like, no more is the sales team going to ask you questions. You're going to build a dashboard that's real-time analytics, and they can go ask the dashboard the questions that has all the data piped on top of it. And now you can also do that even customer-facing too if you want to. And again, this is where things start to get fuzzy on the fact that it feels like we're kind of moving towards there's less siloed databases, honestly. There's just less DBs where it's like, yeah, we've got Postgres and nothing else. Not really. Nowadays, it does kind of feel like it's like we got Postgres, we got Mongo, we have a ClickHouse, and then we also have like Snowflake as well. Like it's just, and everything feeds into Snowflake. All the three feed into Snowflake plus some other stuff. And it kind of feels like that's kind of where we're going. And so everything gets built off of these giant data warehouses. And that's where something like ClickHouse or Elastic or Druid come in, is that we are the real-time analytics database to kind of go on top of this, this cake, quote unquote. So something to note, we are a pretty awesome open source project. We have about 40,000 stars and 7,000 forks, a ton of contributors, more than I could ever name, especially because I can't even name all the ones in my own company. We just have a lot of people who are working really hard to make this project great, and this is some of the people who helped contribute actually to our Delta Lake integrations, or our Iceberg, just data lake integrations in general. And yeah, as you can see here from the star history, I don't know who drew this, but it's cute. I like the squiggliness in the lines. We've clearly been having a really good couple of years as we've been growing quite quickly. And part of that, when it comes to the data lake story that makes us really good, is that we are very good in that we have an unmatched query performance. So we're SQL-based. You just write SQL queries to read from the DB, and we have extremely good query performance for those SQL. Like I cannot I cannot actually put it into words just how fast we are when people use us. It's amazing. We support projections and materialized views, which basically allow you to do materialized views. Basically, allow you to do a computation ahead of time. So you can basically create. You can basically say like every 5 minutes, run this materialized view and give me the answer to the average price data here. Or you could do it like every minute or every hour. So that's very helpful in being able to go over large data sets very quickly and efficiently and do it on a cadence. We have specialized data types, which make us more efficient for actual storage, as well as when it comes to reading data off of catalogs. That's very important as well to have those specialized data types. We have a high insert throughput, which means we're very good at ingesting a lot of data, and we're completely self-contained, which also that comes in from like the open source as well, which is that you can just run the open source on a binary and pretty much call it a day. You don't have to do a lot. So yeah, that's kind of how it looks. Where we feed applications, we have a lot of endpoint options, and then the Clickhouse server itself has this nice storage layer here with these are the like materialized view on top of tables. And of course, we're completely connected in with this entire ecosystem that I just mentioned. So we easily integrate obviously with the data lake. We integrate with cloud providers, things like Snowflake, Databricks, but we also have integrations with streaming as well as other databases. We actually have what we call a query engine where we can just query the other DBs here. And so, yeah, we can just query them directly. You don't even have to always store the data within Clickhouse. So these are some of the query options when it comes to things like data lakes in particular, which is that you can do obviously local queries on data loaded to Clickhouse. That's pretty straightforward. But we can also do federated queries on data in S3. So that's just like directly querying on top of the like Parquet files. And then obviously support for Iceberg, Delta Lake, and Hootie tables as well. And this is kind of like, this is how the S3 table function, for example, would work, which is that you can just do S3 or S3 cluster tables and can be used for things like ad hoc query or for data loading. And it supports more than 70 plus formats. So let's kind of take a look at the architecture, kind of take a look at how people end up using this in real life. So this tends to be what we see as the most common typical architecture and what we also call the fastest data path, because it's basically pretty straightforward in that you just have the data going to two separate places. You have your data lake, which you use as Iceberg or Delta Lake format for what we call long-term storage here. And then you have raw data going into both here, where it's going to be a bit slower on the insert rate into your data lake. And then you have raw data going very fast into something like Clickhouse. And there you actually power, on Clickhouse, you power all of the front-end user-facing analytics dashboarding or other visualization tools or any tools that you're using for customers, basically. Anything that you need to be fast. Basically, it runs off of Clickhouse, and Clickhouse goes ahead and queries your data lake. And something that's interesting here is that you can also add materialized views, which will occasionally query the data lake for updated data as well. We're actually soon going to have the capability of doing a CDC pipeline, where basically we'll look at change data capture and we'll just automatically go ahead and pull from the data lake. But right now you have to occasionally query it out. But yeah, that's something that you can do in case data changes or gets updated there in the data lake. You can go ahead and pull it down and then pull it back into Clickhouse, which is really nice. And this is kind of how it looks as, like, we like to imagine it, like a hot layer versus your cold layer, with obviously things like catalogs as an optional in between, though I personally find that most people should probably use catalogs. I think they're pretty good. I mean, you could just, query directly from the data lake, but catalogs are a powerful tool that are very useful for many, many reasons. And as you can see here, lots of different writers on the left-hand side. Your application, that's the real-time analytics application I was talking about before. And then Clickhouse itself with multiple tables and multiple materialized views. We really do suggest that people take advantage of materialized views, especially when taking advantage of data lakes. And so let's go ahead and wrap this up with climbing the iceberg. So you have your query engines at the top. You have things like Apache Spark, Clickhouse, Snowflake, Trino, and Dremio. That's great. You have so many awesome options. And that's the big thing. They're state-of-the-art query engines. They support multi-level parallelization, and they have advanced caching. That's kind of like, in general, when you're dealing with query engines, those are, I would say, the top three things that you want to see come out of them. Those are the basics that you want to see. And this is kind of some of that query engine optimization. And this is shared between pretty much all the ones that are the most popular. It's not just Clickhouse, to be sure, which is that they are Like I said, multi-level parallelism, they've got at the node, the CPU, and the SMID level. And they have advanced caching, where they will be caching at like the file system, the metadata, preservation of cache locally, and vectorized query execution. These are all a lot of terms for basically saying that things are going to be very efficient when they're querying them out. Then you have what I would, say the security layer. You have your catalog, as well as just a broader connector to the ecosystem. You have broad catalog support. This is in particular to Clickhouse, where you have broad catalog support for things like Glue, Unity, REST, and HMS, credential vending, multiple authentication mechanisms supported, native RBAC, and obviously support for S3, GCS, and Azure. So yes, you can see here with these three catalogs, it's easy to query and also take advantage of object storage as well. And then finally, object storage is where you have your optimizations for open table formats, efficient file format support, and support for metadata features. So that's very important. That's like taking advantage in particular of things like the Parquet file system. And yeah, that's exactly what it's going to say up here. Efficient file format readers like Avro, Parquet, and JSON, which out of those three, personally, I have a strong liking towards the Parquet file system, especially when you're using it with Iceberg. If there's one thing I could say about using Apache Iceberg, please use Parquet files with it. Efficient data skipping, so things like partition-based pruning, statistics-based pruning, and then, as I said before, Iceberg metadata features like snapshots and time travel. So all of these things make it a lot easier to basically shift through your data, like the way that they organize it makes it faster to organize it. That partition pruning is huge. That makes it so much faster to get the data back out, and also makes it so much better for storage and things like running statistics and analytical values on it. All of those things are huge to make it so much better for analytics. Like Parquet in particular, and even Apache Iceberg, these are both built to be better for analytics. That's what they were really made for. Yeah, and this is just kind of showing those partition prunings, as well as things that, like what we would call statistics pushdown. And so what's next? So some of the things on our roadmap in particular are more Iceberg v3 support. We already have some v3 support, but we're going to be focusing a lot more on making sure that support is good for more corner cases, I would say. Like right now we're fixing up some geo supporting and a few other features that are new to v3. An improved Parquet reader, so that way then we can have, we're missing some of the efficiencies that Parquet gives you because our Parquet reader is missing those. So we're going to go ahead and basically wrap that up and put a bow on it. Write support's actually currently in beta. So right now you could go ahead and test it yourself on the open source, where you can write back to your data lake. That wasn't available originally, but now it's going to be available. The CDC pipeline that I mentioned before, where you're going to be able to do change data capture from Iceberg to Clickhouse. And actually coming up in the future will be fully serverless, which is going to be available for Apache Iceberg workloads first, which will basically have things like stateless worker, a distributed cache, and per query usage, all very, very useful for these kind of heavy workloads in particular. And yeah, that's kind of what's here is on this image is the distributed cache service to store the data and metadata, and then a bunch of stateless workers. So yeah, you guys are welcome to connect with us. We also do have a booth just like right outside this door, close to where you get tea and coffee, kind of towards the back. But you're welcome to connect with us on Slack. That's where you can find our entire community, as well as myself, there and available to answer questions. We also have a Sydney meetup group, which I think is great if you'd like to come to any of our meetups or just in general engage with us. It's like we said here, we got meetups and events, community Slack. We have learning materials, like yesterday we did a workshop, but we also have like Learn at Your Own Pace Academy and certifications. And of course, we have try Clickhouse for free. On the Clickhouse cloud, you don't have to like give us a credit card or anything, but you get a 30-day free trial and about 300 USD of credits, which most people love to play around with. And you can also just download and run the open source. Extremely simple and easy to use.